the resistance to the motion of a train due to pressure is 1 over 160 of the weight of the train. If the train is traveling from a level road at 70 km per hour and comes to the foot of an incline of 1 in 150, and the steam is then turned off, how far will the train go up the incline before it comes to rest? We are having an assumption that this thing was moving on a horizontal thing, then it came to here where it was traveling at 72 kilometers per hour. So we have that the initial speed u is equal to 72 kilometers per hour, which is the same as 72 times 10 over 36, giving us 20 meters per second. And now it is we have this 70 km per hour. It is the speed at the point when the train is starting the ascent, and they say that the incline is of 1 in 150. Remember when we talked about an incline of 1 in x, we saw that tangent of theta is 1 over x if this one is the angle theta. We have 1 here, and this side here is x, that side is x, so we have tan theta being 1 divided by x, opposite over adjacent. And for this particular one, we are having 1, that tan theta is equal to 1 over 150. This is 1, this side is 150. And what I need to take note of is the fact that sin theta is almost the same as 1 over 150 also, because if you try to get the hypotenuse here, where you can say that 1 opposite over hypotenuse being the sine of theta shall be getting still 1 over 150, because the hypotenuse there is 150 point some 2 digits here, and then it is very close to 150. So we can able say that sin theta is also 1 over 150. And then when you have that, they talked about the fact that the pressure, the resistance is 1 over 160 of mg. It is the one I'm rendering with this value here, 1 over 160 of mg of the weight. Then we have mg sin theta. That one shall still be there because it is the effect of the gravity, the weight, effect of the weight along with the incline. So it is there. The force which is pushing this thing upwards, they say that the engine is turned off, so that one is going to be 0. If you try to resolve along with the incline, you are going to get that F minus the sum of these two shall get MA. So this is 1 over 160 mg plus mg sine of theta is equal to MA. This one is the resultant. But remember F is 0 because F should be 0 because what we have there is the engine being switched off, so that is 0. Then subtract, this one is 1 over 60 mg plus sin theta, remember, is 1 over 50. So this is 1 over, sin theta is 1 over 150. That is 1 over 150 mg. The mg is that one, the sin theta is the 1 over 50. 1 over 150. That is equal to, the m's will go, and this one is negative 31 over 2400 mg equaling to MA. When you substitute that G is equal to 9.81 meter per second squared, you are going to get that M go with M, they cancel. You are going to get the value of A as negative 0.1266 meters per second squared. Why are we getting that? Because we want to use the fact that V squared the final velocity is equal to u squared plus 2as, where s is the distance covered along the incline. So we are talking about a final velocity which is 0 because how far will the train go up the incline before it comes to rest. So final velocity is 0. Remember, it has started with the velocity of 72 km/h at the foot of the incline. So we have 20 squared plus 2 times now the acceleration along the incline because of the forces which we have there. It is negative 0.1266, then it times s. When this one goes to that direction, you are going to get 2 into 0.1266 s is equal to 400, so that s is equal to 400 divided by 2 times 0.1266, where we shall get a value of s which is that is the value of how far that train is going to go up the incline. You just need to get the value of the acceleration and apply the dynamics of that particular train to get the distance. That's what we have there. Here we have that a train traveling uniformly on the level at a rate of 80 km/h begins an ascent of 1 in 75. The attractive force that the engine exerts during the ascent is constant and equal to 1/100 of the weight of the train. The resistance due is constant and amounted to 1/150 of the weight of the whole train. Show that the train will come to a standstill after climbing for about 2.5 kilometers. So this one is a diagram which is not part of the question. It is a diagram which you are supposed to set up while answering the question to facilitate your answering of the question. While it was on a level ground, it was traveling at the point when it began an ascent. So it came to this point here, which is the foot of the incline, when it was traveling at 80 km/h. So we are going to assume that the initial speed along with the incline, which we have as u, is going to be 80 km/h. This one can be written as 80 times 10 over 36, that is in meters per second. So I have that u, if you work out that, we are going to get 22.2 meters per second. That one is the initial velocity. And when it comes to a standstill at this spot, the final velocity is going to be 0. And our concern here, they have given us that s, they have given us the s, so we want to prove that s is equal to this value here, 2.5 kilometers. So we are not going to use it, but we are going to obtain it and show that it is 2.5. So our concern here is to get the value of a. Once we get the acceleration, we can get the value of this s, and it should be 2.5. So what we are going to do, we are going to get the resultant force and we equate it to ma. So the equation is the forward force, because the train is moving like it was in that direction. So to get the whether acceleration or retardation, we are going to get this one, the forward force, minus this resistive, the forces which are acting in the opposite direction. So I have 1/100, that is mg, minus the sum of these two. This is 1/150 mg. They say that is the resistance. It is here. The resistance due is constant and amounted to 1/150 of the weight. It is that one. Then this other one here, 1/75 mg, is the mg sine theta. Remember, they say that the incline is 1 in 75. That means that tangent of theta is equal to 1/75 and sin theta is also approximately equal to that 1 over 70, 1 over 75. That's what we have there. And if that is the case, remember this is mg sin theta, so mg then times sine of theta. That's how we are getting that this is 1 over 75 times mg. So that one should always be there. Once there is a mass on this one, that mg sin theta will always be there downward along the incline. Whether you have this one as this is the resistance, this is the mg sin theta. We are not taking the mg sin theta as maybe a resisting force. We have the resistance and we have the mg sin theta, which is the component of the gravitational force, that is the weight along the incline. So this 1 over 75 times mg, everything should give us ma. And when you work out here, you are going to get negative, this one is negative mg divided by 100 equal to ma, implying that A is equal to negative g over 100. That is in meter per second squared. But remember g is equal to 9.8. So 9.8 over 100, it means that A is equal to negative 0.098 meters per second squared. Now after getting that as the value of A, we use that v squared is equal to u squared plus 2 times A times s. When the body comes to a standstill, v is equal to 0. But when it was just at the beginning, as it was beginning the ascent, we had the u as 22.2. We have that one squared plus 2 times the acceleration, which is negative 0.098, then times the value of s. We shall take this one on that side, and we have that s is equal to 22.2 squared divided by 2 times 0.098, and this one is going to get us 2514.49, and this one can be written as 2.5 times 10 power 3, that is in meters, which is approximately 2.5 kilometers. And yeah, they said it will come to a standstill for about, you see, it is not exact, but about 2.5, and we can have that. This one is the number of meters which this thing is going to move up the incline, and those meters can be transformed into kilometers as 2.514, which is approximately about 2.5. That is what we have there.